direct mapped technique, right? So this technique, you can able to see that this technique is the simplest form of mapping, right? Okay, so why? Because one block of main memory, so here the memory is represented in terms of blocks. Okay, so why we are able to take the data, so we have to give the memory address, right? So the memory address will contain tags, line, and word. So these three are the contents, right? So the memory will be having, so tag number, line number, and word number. Okay. So and then main memory will be having the blocks. Okay. So here the what is the role of a cache? You can see that. So cache will be having a okay. So you can see that the cache will be having the tag and data. So it is referencing the main memory with the help of a tag. Okay. So here the one. Okay. So this boundary tag represents the tag. So the tag will able to convey, or the tag will having the representation while the memory is free to allocate or not. Okay. So it is like a data structure, so which sits between the blocks in the heap. So heap is just a representation of the memory. Okay, while the memory is allocated. So you can able to find out from this part, right? So the tag, okay, so this tag represents, it sits between the boundary, right? So this is the boundary between the blocks. This is a block, this is the memory block, right? So which is free to allocate. So while this allocated part indicates the memory is ready to, or memory is allocated for the function. Okay, so this is the difference between the memory which is free or memory which is allocated. So at both the ends of every segment, so it there will be two conditions. One is allocated on, another one is free. So the status bits. Okay, so the status bits indicates 0. It the memory is free to use. Okay, and if it is 1, okay, so it is 1 means, okay, so it is 1 means it is allocated. Okay, so this allocated, and 0 means it is free to use, allocate. Okay, not yet allocated. So this is the representation. Here the tag is the boundary. Okay, so it sits between the heap. So the next concept is memory fragmentation. Okay, so you can analyze, or you can from the word fragmentation. Okay, so that is in your laptop or computer, whatever it may be you are using. Okay, so you can able to find out app is called defragment. Okay, so fragmentation and defragmentation. So fragmentation is nothing but the sum of available space in the memory. Okay, so for example, if you are trying to copy a some amount of data, right? So if that particular amount of data is not available, means you will get a error message, or you will get a message like the memory is not available. Okay, so in such case, you will delete the particular contents which are not useful. Okay, you will be able to copy, right? So here the sometimes in some cases the fragmented part, or the fragmented memory, right? So that will be able to satisfy the allocation request. Okay, so here the some of the available space in the memory heap is large enough to satisfy a memory location request, but the size of any individual fragment is too small. Okay, so it does not show, because it does not show that the memory is not available for or memory is not ready to copy, or memory is not ready to take that particular request. Okay, so in this case, that there are two types of fragmentation. Here, fragment what is the meaning of the fragment means? So the scattered data. Okay, so and then we have the types. Okay, before that the heap, which is nothing but a memory storage, and here the dynamically allocated memory, and then you can able to find out the white colors, right? So the white colors is the which is available data. Okay, but it is not aligned. Okay, so it it sits between the allocated space. So the fragmentation, the what is the purpose of a fragmentation means? So in order to collect or in order to combine these white spaces, okay, so into a memory allocation request, so that so the combining the unused or unallocated in a single block or a single space of a memory. So this is what a fragmentation deals with. So here the two types of fragmentation, one is internal and another one is external. Okay, so the internal fragmentation occurs when the memory allocator leaves an extra empty space inside the block. Okay, so here this usually happens because the processor design, okay, will be able to cut down the memory blocks into a certain sizes. Okay, so for example, it is divided by 4 or 8 or 16 bytes. And the external fragmentation means the memory allocated leaves the section of unused memory blocks between the portions of allocated memory. Okay, so this is a difference between internal and external. Okay, so here the several blocks are allocated in continuous line, but one of the middle blocks in the line is freed. The free block is called fragmented. So that free block is ready to use. So this is called external fragmentation. Okay, so this is the ways to improve the performance. So you can try it out, right? You can start and click all the programs, and default in the Windows option there is accessories and system tools. So you can use disk defragmenter and then click defragment now. So this is what Windows and then later versions. So this is the how to improve the performance and how to combine the memory, right? So free memory and how to indulge or how to take the memory request, right? So this is the ways of fighting fragmentation. So and then memory selection. Okay, so this is the one of the essential step in high performance application, because the challenges and the limitations of the system performance are decided based upon the memory. Okay, so these are all the factors. So speed, data storage and size with the capacity, and bus width, and then latency, power consumption and cost. So the cost is the least preferred. Okay, and the most preferred is speed. Okay, and then capacity, data storage size and capacity. So this is what the process of memory selections to be taking place in the embedded system. Okay, so this is what the answer I have quoted down before starting to the session. Okay, so you can blankly write or wrote about the speed. Okay, so but why the speed is very important for selecting the memory? So the data to be accessed very fast, and then in terms of milliseconds or microseconds. Okay, so the data dealing is very important, right? So in terms of accessing, and then low latency should be preferred, because the time taken to fetch the data, or the time interval between the accessing the data and recovering the data, so that is called the latency, right? And also the power consumption. Okay, so these 6 answers will deal with the memory selection for a embedded system. Okay, okay, so that's all. So thank you for watching. So if you have any doubts, you can keep posting in your chat box. Okay, so you can leave